Today, we will talk about classes. What are classes? So, classes are blueprints for objects. I will say this again. Classes are blueprints for objects. Objects contain attributes and methods, and that class is the blueprint for an object containing those attributes and methods. The objectives for today are to create classes, and I already explained the difference between a class and an object. We will again describe the access modifiers. We will write a constructor. We'll probably write more than one constructor. We'll see. We will create getters and setters. What are those? You'll find out in a minute. We will also create a constant using the final keyword, and I will touch on encapsulation and abstraction. Actually, I'll touch upon it now. Encapsulation, that's data hiding. Abstraction means to hide implementation details. We will go into this more in our exercise. Okay, let's look at a sample UML. UML stands for Uniform Modeling Language. It's what we use to determine how to construct, in this case, our class. So a UML looks like this. It's a box. It has our name, our attributes, and our operations, otherwise known as methods. And of course, just a brief review on access modifiers. I have already discussed this in great detail in another video, so you can check that out as well. So public means it's visible everywhere. Within the class, within the package, and outside of the package. Private means that it is visible only within the class. Protected means that it's visible only within the package and only in subclasses. And within the subclass, it's only visible when the subclass accesses it internally. Another class cannot use a subclass to access the method or attribute or whatever is protected. Default is only visible within the package. That's package private. All right. This is our UML for this exercise. Feel free to pause the video to take a closer look. All right, we are back in our IDE, back in Eclipse. Okay, and we are in our Run Classes demo. I think at some point I'm going to have to push this to a repository so that I can share this with all of you. Anyhow, here are the objectives. These are things that we have already discussed. Here's our UML. And what we're going to do is we're going to create this superhero class. Now let's go over what our UML shows. So this is the class name. Our class name will be superhero. These are our attributes, okay? These negative signs, these negative signs, this means private. A negative sign means private. This is a constant. So constants are in capital letters, okay? In this case, it's capital snake case, which are capital letters followed by underscores. And then, of course, here we even have the constructor. This even specifies what our constructor is supposed to look like, okay? This is known as an all-args constructor, and these are our methods, okay? So let's go through these plus signs and negative signs. So a negative sign means private, okay? A positive sign means public. A pound sign, like if I wanted something to be protected, a pound sign, known as a hashtag for those into social media, means protected. So that's the signs. Another thing too, and you'll learn this later, is that if this is in italics, that means it's an abstract class. But we'll talk about that when we talk about abstract classes. Now let's go ahead and create our class. So we'll, so this is our package classes. So we'll right click on classes. We'll go to new, then we'll go to new class. Under name, type in superhero. And then just some other features. If there's a class that you want to extend, you can go here. If there's an interface you want to add, you can go here to interfaces, but we're not there yet. We're just creating a simple class. So let's finish. And now we have a superhero class. Okay. Now, so that we can keep track of what we need to add to this class, what I'm going to do is I'm just going to copy and paste this whole thing. Okay, so now we have some attributes. So we have a name, alter ego, powers and abilities, and catchphrase. And these are all private variables. So this is one of the principles of encapsulation. You want to keep your variables private and access and set these values through getters and setters. That's what encapsulation is. So that hides your data. Now let's create a constant. So the final keyword is a powerful word. So the final keyword, when you apply it to an attribute, that means that once the attribute is assigned a value, it cannot be changed. If you apply it to a class, it means that class cannot be extended. So that means child classes cannot inherit from this class. If you put it on a method, that means that that method cannot be overridden. That being said, let's create our constant. So, and it's static, so it's bound to the class and shared through all instances of the class. I'm just going to copy and paste. And let's give this a value. Sounds pretty reasonable, right? Do good and save people, because that's what heroes do. Okay, next is we're going to create a constructor. So we're going to create a no-args constructor. So classes by nature have a no-args constructor. So let's create a no-args constructor. So you go to source, generate constructor using the fields, and then let's deselect this. So this is a no-args constructor. It calls the super constructor from the object class because every class inherits from object. What is this object, you may ask? Object is a superclass. It's the ultimate superclass. That's what object is. Feel free to look it up. Okay, so now we've created a no args constructor. Now we will create an all args constructor. So let's go to source. Let's go to create constructor using fields. All the fields are pre-selected. So we will generate an all args constructor. Okay. So we have these down, we have these down, so we can just remove this. Now let's create our getters and setters. Before we create all these other methods, including shouting a corny catchphrase, we will create our getters and setters. So how do we do this? Again, if you have a nice IDE like Eclipse or IntelliJ, you go to create getters and setters. Select these and hit generate. So now we have all our getters and setters. So get name returns the name, set name sets the name. And this again goes back to encapsulation. So encapsulation, you make your attributes private and you use getters and setters to retrieve and set the values of these attributes. Why? Because you don't want your variables to be directly accessible by other programs or other classes. So it's in part a security measure. So it secures your variables. That's encapsulation. Abstraction, on the other hand, is when you hide implementation details. We're not going to see it as much here, but when we start talking about abstract classes and interfaces, that's where abstraction really starts to come into play. Okay? And notice that for a constant, there's only a getter. There's no setter. There's no setter because it's constant. Once a constant is assigned a value, you cannot reassign it. All right, now let's create these other methods. Okay, and now we have added the other methods. Save people, do good, and shouting corny catchphrase. So let's look at our class. So overall, we have attributes, we have a constant, we have two constructors. We have our default no args constructor, and we have an all args constructor. We have our getters and setters, and we have our methods specified in the UML. Okay, so let's go back to our run classes demo. Okay. Now let's see if we can instantiate a class. All right, now that we've created our superhero class, let's see if we can instantiate this superhero class. So we will create a superhero. We'll just call this generic superhero. And then we will use the new keyword. And notice we didn't pass in any arguments, but it's not giving us an error. So let's go ahead and print this. So all right, let's run this. Okay, so it looks like it printed superhero, but look, take a notice of what it printed. It's printing the qualified class name. So it's basically printing a qualified class name followed by some hash code. Okay. Why is it? Because if you want to be able to see the attributes of your class, you have to override the toString method. So let's go back and do that. So let's override the toString method. So we'll right click, we'll click source, we'll hover over source, go to generate toString. Okay. All these fields are pre-selected. So let's hit generate. Okay. So it's going to, so this toString method, it returns this concatenated string so that when you print your object, it'll give you some nicer looking output, which is meaningful. Because this right here, I mean, classes.superhero, whatever, what the hell does, I mean, what does this mean? So let's now that we have this toString method, let's run this again. Let's see what we get. Okay, so now we have a superhero with attributes, and these attributes are null because we did not pass them through our constructor. So let's go back to our run classes demo. Let's do something a little let's do something a little more meaningful, and we'll create Superman. He's our superhero prototype, right? So we create Superman, okay? And now we're going to use our all args constructor because before we used our no args constructor. So now we'll use our all args constructor. So name Superman, alter ego. We all know who he is. He's Clark Kent. Those glasses are not fooling me. Powers and abilities. So we'll just pass in this list of powers because the reason I made powers a list and not a single string is because, I mean, Superman, he has all these powers. I mean, I think in one of the movies, he even was throwing styrofoam S's from his chest. Nobody knows what that is all about, but some things in life, you just accept them for what they are. And a corny catchphrase, I make mistakes, but I try to do good. Okay, we'll save this. And let me go back to our superhero class. And we'll change this from I'm shouting a corny ass catchphrase to the actual catchphrase. Okay. All right, let's run this and see what we get. So congratulations. We have created a superhero. His name is Superman, alter ego Clark Kent, powers and abilities. He got super strength, super speed, faster than the speed of a bullet, invulnerable, heat vision. He makes mistakes, but he tries to do good. Just like I try to pass on my knowledge to all of you. So I hope that you guys have learned something about creating classes. We'll do a brief recap. So the objectives were to create classes, which we did. Explain the difference between a class and an object. A class is a blueprint for an object. And we have seen this in our demo. When we construct a class, we determine the structure of the class. We give it attributes and methods and constructors. The constructor means to construct. The constructor literally constructs the class. It takes that blueprint, uses that blueprint, gives the object attributes and behaviors, and constructs an object in that fashion. Describe the public, private, and default access modifiers. I have described them. but it's important to know what they mean on a UML. So public is a plus sign. Private is minus. Protected is a pound sign or hashtag if you're into social media. Write a constructor. Yes, we wrote both types of constructors, right? Getters and setters. We did that. Well, technically, the IDE did that, but you know what I mean. We created a constant using the final keyword. We talked about encapsulation, and we briefly touched on abstraction. Encapsulation, again, is data hiding. You use getters and setters. You make your attributes private and use setters to set the values and getters to get the values. Abstraction is when you hide the implementation details. We have methods. You don't need to know exactly how the method works. It's more important to know what it does. Okay, I think we're done. And until next time, I'm out. Peace.